So today we're going to discuss Module 6, Network Traffic Management. So this chapter we're going to look at network routing and endpoints, Azure Load Balancer, Applications Gateway. So these three topics we're going to look at today. So first topics, network routing and endpoints. Part of this one, we're going to talk about system routes, user-defined routes, routing example, create a routing table, create a custom route, associate the routing table, demonstrations, custom route tables, service endpoints, service endpoint services, and private linking. So these topics we're going to discuss. System routes. System routes direct network traffic between virtual machines, on-premises networks, and internet. Traffic between VMs in the same subnet, between VMs in different subnets, and in same virtual network. And data flow from VMs to the internet. Communications between VMs using the VNet to VNet VPN. Site to site, and explicit out communications to the VPN gateway. As we have looked at previously, networking site, whether VM to VM communications, or one VNet to another VNet, or VNet to on-premises, all kind of areas, we have actually routing. And that routing is provided by this system route. System route is kind of like a Microsoft Azure created route, and that help us to communicate in between different VM, different VNet, and with on-premises network, and also the internet. Let's say you create one virtual machines. Once you create virtual machines, automatically it has routing and all these things enabled. You can download the RDP file, and after that you'll be able to logged into that VM. So over there we have some routing, and that routing is provided by this system route. System route is automatic route enabled in Azure Cloud. An user-defined route, a route table contains a set of rules called routes that specifies how packets should be routed in a virtual network. User-defined routes are custom routes that control network traffic by defining routes that specify the next hop of the traffic flow. The next hop can be a virtual network gateway, virtual network, internet, or virtual appliances. User-defined route will be able to configure, will be able to say what will be the next hop. Is it one virtual machines, one particular subnet, or particular network? We'll be able to create this one. It's kind of like static route or manual route we'll be able to configure in the cloud. The routing example, all traffic coming into the public subnet and headed for the private subnet must be go through the virtual network appliances. This is a virtual network appliances. When public subnets want to communicate with internal network or private subnets, they will go via this virtual appliance. So we can create a routing table, add a custom route that requires all the private subnet traffic be directed to a network appliance. And number 3, we can associate the new routing table with this particular subnet. In this way, we can kind of create default route. Like in on-premises networking environment, we create a default route or static route. Similar things we'll be able to create in here. How to create this routing table? We have to have name, subscriptions, resource group, locations. After that, we'll be able to create. So standard routing protocol is used to exchange routing and reachability informations between 2 or more networks. Routes are automatically added to the routing table of all subnets with virtual network gateway route propagations enabled. In most situations, you'll want to enable the route propagations. How to create custom route? We need to have a name of the route name, particular subnet, and what will be the next hop. We can select either virtual network gateway, virtual network, internet, virtual appliance. We'll be able to select these stuffs. When you create a route, there are several next hop types. In this example, any private subnet IP address will be sent to the virtual appliance. Other choices are virtual network gateway, virtual network and internet, and none. So when you add the route, then you'll be able to specify the next hop. And this is how to associate the routing table. We need to have a name for that, and our private subnet, NAT, and then routing table we configured previously. We need to select that one. Each subnet can have 0 or 1 routing table associated with it. In our example, public subnet will be associated with the routing table. So we can create a routing table. We can add the route. We can associate routing table with a particular subnet. So these kind of things we can do. And later on, we're going to check how to do these steps. Another thing we have called service endpoints. Service endpoints limit network access to specific subnets and IP address. Endpoint is kind of address, improved security for your Azure service resources, optimal routing for Azure service traffic from your virtual network. Endpoints use the Microsoft Azure backbone network, simple to set up with less management overhead. Such as in here, we have a service endpoint. Service endpoint is kind of like a locations or address. Like if you want to associate with something in the cloud, you need some kind of locations, address, or device. Because we do not have any device, they're all virtual. That's why we have the service points, service endpoint. Express or public peering or internet access to the NAT IP. This is on premises, and this is Azure storage. So the one service point will be in here, another service point will be here. So Microsoft provide all these service endpoints, such as Microsoft Azure directory endpoint, database endpoint, key vault endpoint, SQL servers endpoint, storage endpoint. Endpoint means a kind of like locations. Let's say on premises, you can say one device that is endpoint or end user device, or that is the end device. It's similar to, we have some services in the cloud and they have specific locations, and that is called endpoints. Adding service endpoints can take up to 15 minutes to complete. Another thing we have called private link. Private link, private connectivity to services on Azure. Traffic remains on the same Microsoft network with no public internet access. Integrations with on-premises and peer networks. In the event of a security incident with your network, only the mapped resource will be accessible. Let's say you have some database services in the cloud, and from on-premises, you can access those database services. But any security issues happen, those services, without having the internet publicity, you'll be able to access with this private link. That means it's kind of like a private connections. If something happen, you'll be able to still access those resources. You do not need any public access or public internet to access these stuffs. Mostly data, some services, let's say you have over there, and some security issues happen. So during that time, these things will not be accessible from the public internet. That's what he's saying. So you'll be able to access those stuffs with that private link. So it's kind of like a secured link. So this secured link, you can map with your on-premises services as well. So this is another options we have in the cloud, private link. Because majority of the services we accessing via internet, the public internet, but this one is a kind of private connectivity. It's kind of like wide area network connections, but um, it's called private connectivity in here. So these things we're going to look at. So another thing we have called Azure Load Balancer. So we'll discuss all these things, then we're going to do this lab. Azure Load Balancer overview. Part of this one, we're going to discuss Azure Load Balancer, public load balancer, internal load balancer SKUs, backbone pools, load balancer rules, session persistence, health props. So these topics we're going to look at. Azure Load Balancer, what it does, it distributes inbound traffic to backend resources using load balancing tools and health props. Can be used for inbound and outbound scenarios. We have public and internal, two types of load balancer. So load balancer is, for example, you have some applications running in these virtual machines, and many people accessing these applications. You can do the load balancer. The load balancer, you can distribute some traffic to this one, some traffic to that one, some traffic to that one. So this is really, really very good features in the cloud, especially if you deploy any applications, and if you'd like to do load balancing, you can do in this way. Public load balancer, let's say any web applications. So that applications, many people accessing, this is a web applications. So when you try to use that applications, this load balancer will distribute the traffic to this one, or that one. You can add many different services, many different virtual machines with this load balancer. Maps public IP address and port number of incoming traffic to the VM's private IP address and the port number, and vice versa. Apply load balancing rules to distribute traffic across the VMs or services. We can have internal load balancer as well. Let's say those virtual machines, people accessing from outside, but this VM, they actually has connections with other database services. So this VM need many database services, so we can do internal load balancing as well. In this way, let's say this VM need some information from these servers, SQL servers. It may be directed over there or over there or over there. We can do load balancing internally as well for internal services. So directs traffic only to resources inside a virtual network, or that use a VPN access Azure infrastructure. Front-end IP addresses and virtual networks are never directly exposed to an internal endpoint. Enables load balancing within a virtual network for cross-premises virtual networks, for multi-tier applications, and for line of business applications. So these are the purposes we can use this internal load balancers. They're really good features in terms of applications deployment, application services around that. Load balancer SKUs. SKU stands for service key or software key units, right? They are plan, like a standard, basic, advanced. They are kind of like a plan. Load balancer supports both basic and standard SKUs. SKUs are not mutable. Only standard load balancer rules can span two virtual networks. No charge for the basic load balancer SKUs. So this is the load balancers, internal, basic, and this is our VNet and subnet. But we are looking at only this part. Basic, you have some standard features, but standard, you'll have a bit more features. Backend pools. To distribute traffic, a backend address pool contains the IP address of the virtual NICs that are connected to the load balancer. So backend pool, basically, it's contain the NIC card. Basic SKU, VMs in a single availability set or VM skill set. Standard SKU, any VM in a single virtual network, including a blend of VMs, availability sets, and VM skill sets. So this one only support VM in a single availability set. That means this basic kind of load balancing it will do, but this one support single virtual network, VMs availability set, and VM skill set. So standard has a bit more features. We have a bit more load balancing features. So backend pools, basically it's contain the virtual machines IP address and NIC card informations. And backend pool actually connect the VM NIC card with the load balancer. And we can use some load balancer rules. Maps a front-end IP and port combinations to a set of backend IP address and port number. It's saying that front-end IP address, let's say your web applications IP address, will be able to connect with these virtual machines, and you can add the port number as well. Rules can be used in combinations with NAT rules. A NAT rules is explicitly attached to a VM to complete the path to the target. Now, this is the scenarios. When you create the load balancing, this is our load balancer. Let's say we're going to create this one, and then we're going to create virtual machines 1, 2, and 3. So when you create the load balancers, we're going to add backend pools and also front-end IP address. And we're going to create some rules. So in this way, when traffic comes into this load balancer, traffic will distribute to any of this particular VM. And this section is talking about session persistence. Session persistence means how the connections will happen with each of the VM. If you say none, then connections will go to any of the available VM. Right? Session persistence specify how client traffic is handled. None means request can be handled by any virtual machines. Client IP means client IP request will be handled by the same virtual machines. Client IP and protocol specify that successive requests from the same address and protocol will be handled by the same virtual machines. So IP and protocol will be managed by the same virtual machines. By default, this is none. So whatever service is available, these connections will go to that services. Health probes allows the load balancer to monitor the status of an app, dynamically adds or removes VMs from the load balancer rotations based on their response to health checks. HTTP custom probes pings every 15 seconds. TCP custom props try to establish a successful TCP connections. So this kind of monitoring features we have. So based on your response time, based on your traffic, it can add and remove the VNs with the load balancer in a rotating basis. So this health probe also very important in our load balancing side. So these things we're going to configure and then we're going to look at all these steps. Another sections we're going to discuss, this is Azure Applications Gateway. Part of this one, we're going to discuss Applications Gateway routing, Applications Gateway configuration. So gateway means a router, right? Applications gateway means it will direct the traffic to particular applications. So when you browse any applications based on your requirements, it will direct the traffic to either one VM or set of VMs or in on-premises servers. Applications gateway manage web app request, routes traffic to a pool of web servers based on the URL of a request. The web servers can be Azure virtual machines, Azure virtual skill sets, Azure app services, and even on-premises servers. So it can be direct to any of the locations. So when traffic will come, when they want to access some applications, so this applications gateway will direct the access to a particular applications. It could be inside the VM, it could be set of VMs, it could be on-premises services. So it will direct the traffic based on the rules. This is more on application management areas. We can use this one. Let's say applications gateway routing. We have a path-based routing or multi-site routing. Path-based routing means when traffic comes to this gateway, then traffic may be directed to that particular servers where you have image or that particular servers where you have videos. Or multi-site routing means multiple domain. Maybe when traffic come into your gateway will direct the traffic to this domain, Contoso pool, or this domain or Fabricam tool. So applications gateway will direct the traffic to proper destinations. Application gateway components, we have front-end IP, we have listeners. So it defines the VIP or IP for load balancing. Front-end listener on a port, IP or certificate. What kind of port and protocol? So it will listen that informations. Port number and certificate. After that, rules. In our applications gateway, we'll have some rules. Rule stitches front-end to back-end traffic. So it will send the traffic to right directions. Settings for back-end traffic, port, stickiness, probe, and timeout. So it is HTTP settings, custom probe, or back-end pool, back-end instances. It may be sent over there or it may be sent these sites. So rule is associated with these features. So applications gateway is another features. With that, we can pretty much direct the traffic to the right applications. Now let's have a look some labs around that. Now we're going to do one of the lab, and that will pretty much cover many steps. So at first, we need to create load balancer. So first thing, we're going to say load balancers. In the search options, we're going to find out load balancer. And then we're going to create this load balancer. Say create load balancer. After that, after that, we need to select resource group. In here, we're going to create new resource group. We can say, I'll say LB load balancer resource group. I'm just creating new resource group. And I'm going to select the particular locations. I'm going to select West Europe. West. No, this is the name. Resource group. This is the name of the load balancer. We say my load balancer. My load balancer. Load balancer. This is just the name for the load balancer. We can say my load balancer. After the region, we're going to select West Europe, let's say. And this is public load balancer. And SKU, we select standard. Okay. After that, regional and global, just select regional, default is okay. Public IP address, we're going to say my public IP. This is just the name we need to put. After that, IP address assignment, public IP, these things leave it default. We're going to use Microsoft Network, that's fine. Is it okay? Are you following?
Yeah.
Cool. Daniel, you okay? Daniel, you okay?
Yes, all good.
Okay, all good.
Thanks.
Thank you. So once we fill up, then we say review plus create. Now validation passed. Once validation passed, we click on create. Rohitesh,
Yeah.
when you're creating, because you're creating in the same portal, so you need to use the different name.
Okay.
A different name means, for example, I said, sorry, I forgot to tell you. Because I use that name, you're creating in the same place. So you need to say my, or you just say anything you create, just before that you put R. R means your name, Rohitesh, okay?
Well, okay.
Just say R load balancer 1, like that. Or whatever I put, you just put, you just use the different name. So you put R and keep the same name if you like.
Okay.
So let's see. I can check as well. So this one created. So you can create another one in here. Okay.
Okay.
Or I can actually create another one. Also, you can use this one. I'm creating another one. Is it okay?
Oh, okay.
Okay. So just wait for a few moments. I'm creating another one.
Yeah.
So mine one, I'm going to select the same resource group, or I can actually create a new one. ZLB resource group. That's mine one. Name Z load balancer. And West Europe, that's fine. Standard regional, create new Z my pub IP. and availability. My public IP address, that's two redundancy and this create. Now I'm going to open my load balancer. And at first we're going to create backend pools. So I'll click on backend pools. And after that, I'll click add. And I need to name, I say Z my backend pool. This is the name of the backend pool.
Okay.
Other things, leave it default. We do not have to select virtual network or NIC card or anything else. Just leave it default and click add. Just put the name and click add. So we need to wait here. It's validating. After that is done.
Yeah.
So we're going to create health props. Once this one done, we're going to click on health props. And we're going to add health prop. Name it my health prop. And protocol is TCP. Protocol actually we select HTTP, port number 80. Path leave it default. Interval we put 15 seconds. Oops. And unhealthy threshold 2, that's fine. Used by not used, and click add. Okay, this is the health prop informations. So it's creating the health prop. It's good. So this one is done. Now next is load balancer rule. We're going to click add. Name it my HTTP rule. And IPv4 front-end IP address. Front-end IP address, we're going to select this one. This is the only options we have. Load balancer front-end. Then TCP port number 80. Backend port also 80. If we go down a bit, backend pool, it should be my backend pool. Health prop, it should be HTTP prop, that one we just created. Session persistence none. Ideal timeout, we put 15 minutes. And TCP reset, we just say enabled. And floating IP, leave it default. Outbound source network, that is recommended. Use outbound rules to provide backend pool members access to the internet. Leave it default. So once you configure these steps, we click add. Okay. So I have created my load balancer, and with that, I've added backend pools, health props, and load balancing rules, these three things. Is it done so far for you?
Yeah, it's done.
Cool, excellent.
Yes, mine's good.
Cool, excellent. Now, next thing, we're going to create virtual network. So we'll click on this menu. We go to virtual network.
Virtual network.
So we're going to create virtual network. And virtual network or resource group, I'm going to select my own resource group, which is ZLBRG, and name it. I'm going to name mine one Z VNet 1. That's mine one. Then IP address. So IP address, mine one is showing this subnet.
Yeah.
Ritesh, your one is same or?
Yeah, same thing.
Same thing, okay. You keep the default, I'll change mine one, okay?
Okay.
I'll put mine one 10.1.16.0. I'll change it just a bit. 10.1.00/16. And after that, I need to add subnet. And I'll name it my backend subnet. My backend subnet. And subnet range will be 10.1.0.0/24. And net gateway, leave it default. All you have to do, just add subnet, and our main subnet is /16, but under this one we have a /24, this subnet.
Okay.
We're going to click add. So that's good. Now next, security. In security, we're going to create Bastion host.
Right.
So Bastion subnet is another subnet we need to add with our network. So in this network, if we create any virtual machines, always whatever virtual machines we create, always we'll be able to connect with this, Bastion, because Bastion is kind of like a, IP interface. With that, always we'll be able to connect with this VM. So we are going to add this one. Enable name my Bastion host. My Bastion host, and subnet. I'm going to use 10.1.1.0/24. In your case, you're going to use 10.0.1.0/24. Okay?
10 dot
Because your network is 10.0. So you should use 10.0.1.0/24. And it should be ticked like that.
is so 10.0.1.0
Yes.
/24. Okay.
Yep.
Yeah.
Public IP address. Public IP address, say create new and say my Bastion IP. Z my Bastion IP. So it will create another public IP address for this Bastion subnet. And click OK. You just need to put a name. After that, we have tags, review plus create. Validation passed. I'll say create.
Deployment in progress.
After that, once it's done, then we're going to create virtual machines over there. Okay. Then you go to menu. Then you're going to click virtual machines. Next things, we're going to deploy virtual machines. But these virtual machines we need to deploy in this subnet, in this network, and also in the load balancer. And also we need to have one standard rules for that. So you're going to create virtual machines. After that, I'm going to select my resource group, ZLBRG. Virtual machines name, we can say VM1, West Europe. Availability options, we're going to select availability zone. And inside the availability zone, we're going to select zone 1. So when you deploy the virtual machines, we need to select the zone. And image Windows Server 2016 data centers, we can select this one. And we have this size of the disk, that's fine. Then account name, I'll put my name and my password. Oops.
Hey, Zahid.
Yes.
When I try and create it in zone 1, under the size, I'm getting an error. This size is not available in zone 1, 2, and 3. So I think
can you select anything?
I can only create it under zone 2 on my end rather than zone 1. Is that okay?
So yeah, so please select zone 2 in your case, yes.
All right, no worries.
With the free subscriptions, this kind of things happen. Like particular zone, they don't allow you to create things like that. But you please select zone 2. Now this one, Rohitesh, when you create, make sure all the name should be different, right?
Yeah, I've created all my
Cool.
initial in front.
Good. I put Z, West Europe availability zone and stuff. This is my username. You put your username and your password. So I have my username and password. I think that's fine. And allowed selected port. See the public inbound ports, you can click none. We can fix this one later on, but just put none here is better. Because we're going to create one of the rules and we allow certain ports over there. So you can click none. After that, we click disk. Disk, we don't have to do anything, it will be default. Click networking. So when you do networking, we must select our VNet 1. Okay. After that, network security group. This is like an NSG group rules. We click on advanced and we're going to create new rules. And this rule we apply to other VMs as well, same rules. So we're going to create rules. And this one, name it ZNSG rule 1. That's my rule. And add inbound rules.
SG.
Okay, I have named it and say add inbound rule. And after that, I'm going to select destinations port is 80 and priority, protocol, any actions, any allow, and priority you put 100 and name it Z HTTP rule. That is my rule.
HTTP.
We just create one inbound rule. So we open the port number 80 and we allow them. If you put the priority 100, lower the priority, that rule will apply at first. So that's what we are creating.
Okay.
After that, once it's done, click add. So this is my rule. And click OK. So it should be selected ZNSG rule 1. So that's my rule added. That's fine. If we go down, see the load balancer, we click tick over there. And load balancer options, Azure load balancer, select a load balancer. I'll select my load balancer, which is Z load balancer 1, this one. And it will select my load balancer pool.
My backend pool, right?
Yep. Okay with that?
Yeah. The next.
Next is management. Management, this monitoring boot diagnostics we do not need. This is a different service and other things leave it default. Click next advanced. These things we do not need. Tags we do not need. Review plus create.
Validation passed. Create.
And click create. So this is our first VM we are deploying. After that, we're going to create another VM. I'll go to virtual machines again and create virtual machines. And I'm going to select resource group. Name it ZVM2. This is my second VM. Availability zone. I'm going to select availability zone and zone mine 1. It should be 2. And size is okay. Username Sahid. Then you go down. Public inbound port, none. And after that, if we go down, click disk, networking, disk, we don't need to do anything. But networking, again, we need to be careful in here. Make sure your correct VNet, correct subnet. And when you say public IP, just click none. Public IP should be none. And network security group, advanced. And over there, it should be Z NSG rule 1. Okay. Same rule should be for all VM. And public IP should be none. These two things need to be careful in here. Because this VM kind of like creating in the same place, they will be part of the same thing.
Okay.
After that, we go down and select the load balancer. So load balancer will be Z load balancer 1 and Z my backend pool. Okay, so we're going to deploy this one in the same load balancer. This part, this is the main part. After that, they are all general thing. Okay. Advanced tags, review plus create. So now this two VM is creating. You can deploy more VM over there, but in our case, it two should be fine because we can check the load balancing within these two virtual machines. Now, after that, next thing we're going to look at outbound rules. So I'm going to select my load balancer from the search menu. And this is my load balancer. I'm going to create outbound rules. Load balancer, always you find in the search menu. So I'll create outbound rules. And click add. This one I'll say Z outbound rule. Front-end IP address. We can select only one, this one. So these options we have only. Protocol. Port allocations, it's saying manually this stuffs, outbound port rules, port by port per instance. And in here we put 10,000. So randomly 10,000 port will be able to access the services. Maximum number of backend instance 6. The other things leave it default. Okay. Then click add. Now, if I go to my backend pools, these two VM is running. So this part is create outbound rules. After that, in outbound rules, we just need to add these virtual machines. So these virtual machines to outbound pools. So basically, if you create on select my backend pools outbound. These two VM, we just need to tick and click add. So this one we don't have to do because I think this is already added in here. Just if you click save, it's already added, so you don't have to do this part. It's good. After that, once you got this VM, now these things we're going to check. We click on virtual machines, and we're going to log into our virtual machines. I'm going to select my VM1. Now I'm going to open my VM. I'll go to my virtual machines. I'll go to VM1. I'll just connect to this VM. Click on connect. And this time is Bastion. Click on Bastion and say use Bastion. And just need to put username and password. Connect. So I'll go to my second VM. Just put username and password. Once you put username and password, then it will open in the browser. Okay, so this is my VM1. And that is my VM2. So now you can access your VM from the browser. VM2, this side, VM1. Okay, I got now VM1 and VM2. So next thing what I'll do, I'll just change the script. Currently, we have a default IIS servers in here. So we're going to install the IIS servers and we make some changes. So now in our virtual machines, we're going to install IIS servers. And after that, we're going to make some changes in here. So I'll copy this PowerShell command in here. You can use the same. Simply, we're going to copy paste. So I'll copy this one. And then I'm going to open this virtual machines start menu. And there's a PowerShell. I'll click on PowerShell and right click. If I right click, it will install this IIS servers, and also it will change the default name for that IIS servers. Same thing, I'll go to my VM2, start menu, PowerShell, right click. So I'm going to install these web servers. After that, it will remove the default one and create the new web server page. So this one is done. Other one is almost done. Yeah, both of them done. So the servers, once we install this one is if we open the Internet Explorer on that VM, it will just display, if I say local host, if I type local host, hit enter, it should be saying hello world from my VM. If I go to the other one, browser, okay, just say local host. Ooh, this one I don't need. Yes, I've added everything, close. Oh. Local host. It should be saying so. Both of the VM, from the web servers, it's saying that hello from VM1. Other one is saying hello from VM2, like that. So that means both VM will be able to recognize from outside. So once this is done, then we can check our load balancer. We'll go to menu. We go to our load balancer. And our load balancer, we have the public IP. If I go to my load balancer, mine one public IP address is 234.180. How about the Rohitesh one? See, you got different one because we created different, so you got 138. That's fine. If I go to load balancer 1, and this is my public IP, I'll copy my public IP, and I'm going to place anywhere in the internet. So they are routable to the internet. I'm going to open my browser, and oops, those things I don't need. I just need IP address only. If I browse that one, it's saying hello from VM2. That means currently VM2 is responding when we are accessing these particular web services. But if something happened with VM2, or if VM2 is busy, let's say VM2 is busy. This is VM2. If I right click, and for example, if I shut down, it's shutting down. So if I go to my browser, if I do refresh, look at that. It says hello from VM1. So that means our public IP and public IP under that, whatever web servers we have, we can access that one. Even other one is down, but this one is working. Down or busy, we just make that one busy, engaged. So if it is engaged or busy, we can see that other VM is responding. So that's how it kind of do the load balancing. If I start that one again, I'll go to my virtual machines. This is my, see, VM2 is stopped, so I'll just tick that one, start. So it takes a couple of minutes. Once it's start, if I check this, my web server, then I'll be able to see that VM2 is responding. Not yet not yet. So from the back end, it's actually preferred the VM2. So those things you can configure. That's another part, but I think VM2 should be fine once you got that one up and running. So you go to VM2. Then I'll click on connect. And see the advantage with the Bastion, you don't need to download the RDP. You can browse that one from the web servers or web browser. Connecting once it's up and running, then it may go back to that VM2. Oh no, not yet. But how about if we restart this VM1? Right click on the corner. Restart. This one, sorry. Need to go to there, to refresh. It should pick up VM2 now. It's a bit slow process, but so yeah, VM2 is not ready yet. So VM2, once you check the readiness, VM2 is now ready. Let's see in here, refresh. Oh, not yet. Now this is VM1. Right click, shut down. See, now it's gone up. So it's from there. But if I do here, look at that. Now it's responding from VM2. That is the main idea with this load balancing.